I'm working off of Unit 9, Worksheet 3, molar concentration. I'm going to do number 6 and number 10 in this video. You do need your periodic table, a calculator, and probably your polyatomic ion list if you have not yet memorized those, but you really should have them memorized. So in number 6, 45.3 grams of potassium nitrate is dissolved in enough water to make 225 milliliters of solution. You want to determine the molarity of the solution. Okay, so let's think about what molarity even means. Molarity, or big M, is the number of moles of solute, in this case it's potassium nitrate, divided by the total number of liters of the entire solution. So to figure out the molarity of the solution, we need to figure out how many moles of potassium nitrate we have and divide it by the total liters of solution. So let's figure out how many moles of potassium nitrate we have. They told us that we have 45.3 grams, and we want to convert that to moles. So to convert between mass and moles, you have to use molar mass of KNO3. So that has, this is when we look at our periodic table, we have 3 oxygens, and each oxygen has a mass of 16. We have 1 nitrogen, and we have 1 potassium. So adding all of that up, you should get a molar mass of around 101 grams for every 1 mole. But we don't even have 101 grams, we have less than that. So we will probably end up with getting less than a mole. So we want to put our 101 grams on bottom so it can cross cancel. We're going to put our 1 mole on top. So 45.3 divided by 101 should get us 0.45-ish moles of potassium nitrate. So that's what I write in right here. Now I want to figure out how many liters solution I have. They gave me milliliters, so I need to convert milliliters to liters. And I know that there are 1,000 milliliters in 1 liter. And so if you divide by 1,000, you should get 0.225 liters total. So when you divide these, 0.45 divided by 0.225, you should get around 2 moles per liter, which we can shorthand as big M. So the solution is 2 molar, that's its concentration. So that means for every 1 liter of solution, we have 2 moles of potassium nitrate. So we can use molarity. If we're finding molarity, we want to just plug in moles and liters of the solution to get your molarity. But we can also use molarity as a conversion factor to convert between moles and liters. So that will be done in number 10. My Kool-Aid. So number 10, we are trying to prepare a 0.1 molar silver nitrate solution, but we only need 250 milliliters of it, so we're not going to make a whole liter, just 250 milliliters. So we want to figure out how many grams of silver nitrate we need. So if you remember, silver nitrate is AgNO3. And like I said earlier, we can use molarity to convert between moles and liters, because 0.1 molar means that if I have 0.1 moles of solution, that means I have a liter of it. Or every liter of solution contains 0.1 moles of silver nitrate. So they gave me volume, 250 milliliters. I can figure out how many moles of silver I need, and then from there convert my moles to mass. So let's figure out first how many moles of silver nitrate we need. Now, there's an issue. To use molarity as a conversion factor, my volume has to be in liters. Right now it's in milliliters. So to convert that to liters, I use the fact that I have 1,000 milliliters in 1 liter. So I have 0.25 liters. And I want to figure out how many moles of silver nitrate I need to make a 0.1 molar solution. And 0.1 molar means that for every 1 liter, I should have 0.1 moles. So 0.25 times 0.1 should get me 0.025 moles of silver nitrate. So I need to put in to my little itty bitty 250 milliliter flask 0.025 moles. But again, we don't have a molometer. We have to figure out what mass that is so I can actually measure that. So to convert between moles of silver nitrate and mass of silver nitrate, use a molar mass of silver nitrate. So take a second, look at your periodic table to calculate the molar mass of silver nitrate. You should get the molar mass of this to be 170 grams per mole. So that means every 1 mole is 170 grams, but we don't have even a full mole, so we should have less than 170 grams. We put our 1 mole on bottom so it can cross cancel, and 170 grams on top. So 0.025 times 170 should get us 4.25 grams. And yay, we got the answer. So again, it's good to go back and think about what just happened. So we wanted to figure out how many grams of silver we needed to put into our little 250 milliliter flask if I wanted a solution of 0.1 molar. So what that means is that for every 1 liter, I should get 0.1 mole. I need 0.1 moles of silver nitrate. But I don't even have a full liter. I have about 1/4 of a liter. So I need to figure out how many moles I will need in just that little bit, my 250 mil. So use molarity as my conversion factor to convert between liters and moles. And from there, I can figure out what mass this is by using the molar mass of silver nitrate.